This video will explain how to apply the unipolar PWM control technique to single-phase half-bridge and full-bridge inverters. Since the positive and negative half cycle of the output voltage waveform will be generated using different power switches, thus, we need to generate two PWM control pulses. To do so, we will use the following signals. An ideal sinusoidal waveform is used as the reference signal for the power switches that generate the positive half cycle of the output voltage waveform. However, the reference signal for the power switches that generate the negative half cycle is an inverted sinusoidal waveform. For simulation work, you may use the following diagram to generate PWM control pulses for a single-phase half-bridge inverter. The same simulation diagram can also be applied to a single-phase full-bridge inverter. This time, I will apply the control strategy to a single-phase full-bridge inverter with resistive load. As you can see, the simulation block diagram is following the block diagram sketched in the previous discussion. By using this simulation diagram, the control pulses generated are as follows. By using these control pulses, the output voltage waveform of this inverter will look like this. The width of the PWM control pulses is affected by two parameters, which are the amplitude modulation ratio or modulation index and the frequency modulation ratio or carrier ratio. The modulation index is a ratio between the peak amplitude of the reference signal to the peak amplitude of the carrier signal. These figures show the effect of using two modulation index, which are 0.75 and 0.5 respectively. For this example, I manipulated the amplitude of the reference signal to obtain the desired modulation index. However, in the actual practice, we need to modify the amplitude of the carrier signal instead of the reference signal, especially when we use a closed-loop control system to regulate the operation of the inverter. Otherwise, the output voltage waveform generated by the inverter does not have the desired amplitude. Meanwhile, the carrier ratio is a ratio between the frequency of the carrier signal to the frequency of the reference signal.